Okay, so you need to find a software bug, and you need to find it fast. What's your weapon of choice? A sniper rifle or a shotgun? Now, I know that sounds like a strange question, but it's at the very heart of a fascinating study on software testing, and we're about to find out which approach wins when the clock is ticking.
You know, the world of modern software development is all about one thing: speed. It's code, test, deploy, faster, faster, faster. This whole continuous integration and deployment pipeline, CI/CD, it demands that we move from new code to a live product as quickly and as reliably as we possibly can. Every single second counts.
And I'm not kidding when I say every second counts. Most experts suggest that a reasonable time for the entire build and test cycle in a pipeline is just about 10 minutes. That's it. That is an incredibly tiny window to make sure your latest change didn't just break everything. So, that brings us to the crucial question, right? If you've just pushed a small code update, how do you use those 10 minutes in the smartest way possible to sniff out any new bugs you might have just created?
To figure this out, we're going to use this brilliant analogy, the sniper versus the shotgun. This really helps us understand two competing philosophies in a type of automated testing that's called fuzzing.
So on one side, you have the sniper. This is what we call directed fuzzing. It's incredibly precise. It aims right at the new lines of code you just added and focuses all of its energy right there. Then, on the other side, you've got the shotgun. This is undirected fuzzing. It doesn't really aim at anything specific. It just blasts the whole program with a wide spray of tests, hoping it hits something.
Now, common sense would tell you the sniper is the obvious choice here. If you changed a specific part of the code, you should test that specific part, right? It just feels more efficient, more logical, just plain smarter. But is it?
Well, a group of researchers at the University of British Columbia put this exact question to the test inside a simulated CI/CD environment. And the winner they found? Well, it was genuinely surprising.
So here's how they set it up. The goal was simple: find the most bugs you can in that 10-minute time limit. But here's the really important part, the key condition. They didn't start from scratch. Every single test began with a rich set of existing test cases. They called it a seed corpus that had already been built up during a previous 24-hour fuzzing session. This setup is a lot like a real-world scenario where you're constantly building on previous tests. So with that really rich starting point, which approach do you think came out on top? The focused sniper or the broad shotgun?
So the results are in, and it's a tie for first place. The classic shotgun fuzzer, known as AFL, found the same number of bugs as TuneFuzz, which is a smarter fuzzer that automatically targets code. They both found 6.2 bugs on average. But get this, the traditional snipers, the ones that were manually aimed right at the code changes, they actually found fewer bugs. But wait, because there's a bit of a twist. In the super high-speed world of CI/CD, it's not just about how many bugs you find. It's about the total time it takes from start to finish, and that includes all the setup time the fuzzer needs before it can even start its work. And here is the final verdict. When you factor in that initial setup time, the simple lightweight shotgun, AFL, is dramatically faster. Its total time is way down here. TuneFuzz, while it's effective, needs a lot of heavy setup, which makes its overall time much, much higher. So the crucial point here is, the shotgun isn't just as good, it's actually way more efficient in a real-world pipeline.
Okay, but this result is completely counterintuitive. Why would a less focused approach actually be better? Well, the answer lies in the experiment's secret weapon.
It all comes down to that key condition we talked about earlier, the seed corpus. This wasn't just some random collection of tests they started with. It was built over 24 hours of continuous fuzzing, which means it was incredibly powerful and really comprehensive right from the get-go.
And here it is, the aha moment, straight from the researchers themselves. They found that almost all of the bugs weren't discovered by the fuzzer cleverly creating new test cases during that 10-minute sprint. No, they were found just by running the existing test cases from that powerful seed corpus against the new code.
In other words, all that heavy lifting had already been done. The so-called smart targeting of the sniper approach, it was totally irrelevant, because the simple act of rerunning the old tests was enough to expose the new bugs. The bug was already caught in the net they had built beforehand.
So this reveals a totally different way to think about it. The most effective strategy is really a two-step process. First, you run the marathon. This is an intensive, long-running fuzzing session that you do offline to build that amazing, high-quality seed corpus. Then, when it's time for your CI/CD check, you run the sprint. You just take that corpus you built and quickly run it against your changes.
Okay, so let's break this down. What does this all mean for you? For anyone who's actually out there building and testing software today? What are the real, practical takeaways here?
Well, here's what it means for you. First, a simple, fast shotgun fuzzer can be your absolute best friend for CI/CD. Second, you gotta remember that the magic isn't in the 10-minute test, it's in the 24-hour preparation. So invest your time and energy into building a high-quality seed corpus offline. And this means you should think of your CI/CD test more like a rapid regression test, not some deep, new exploration. Because ultimately, a heavy, complex fuzzer setup can just slow you down without adding any real value in that short window.
And all of that leaves us with a final question to think about. This study really shows that the fastest sprinters are often the best prepared marathon runners. So it's worth taking a look at your own process and asking, is your testing strategy built for the sprint or is it built for the marathon?